Another hello. No, it's not a hello from West Virginia. I gotta get home somehow. But I am enjoying the travel. I'm enjoying seeing all this scenery. This is great. The other great thing is joke of the day, and I know you're ready for joke of the day. Let's get to it. Which side of the turkey, turkey has the most feathers? Which side of the turkey has most feathers? The outside. Oh, joke of the day is the best, isn't it? Well, now we're going to take a look at solving our systems of nonlinear equations by the method of elimination, also called the method of addition. Now, mathematicians are not creative. We call it like we see it. So if it's called the method of elimination, that means I'm going to eliminate something. What am I going to eliminate? A set of variables. Now, how am I going to do it? By adding up the two equations. So let's review real quick that if we have a system of equations, and you can see a system down here, that is a set of equations that can be solved simultaneously for a common solution. So I am looking for the point of intersection of the two graphs. Now these two graphs are they're actually going to be circles. Well, one's going to be a hyperbola, not a hyperbola, but one's going to be an ellipse and the other one's going to be a circle. But the point is these are curves, so there's going to be multiple points of intersection. But in order to find those points of intersection, I'm going to do this method of elimination, also called the method of addition. In order for this to happen, I need to be able to add the equations so that one of the variables is eliminated. That's the whole goal, and again, that's why this is called the method of addition at times, because you're going to add the equations. Also called the method of elimination, because you're going to eliminate a set of variables. So take a look at what I have right here in this example. Notice that if I go ahead and I add up these equations right now, I want a different color here. If I add these equations right now, then I'm going to get 4x squared plus 4x squared is 8x squared. Negative y squared plus y squared will cancel out. And then 4 plus 4 will give me an 8. Notice that I'm down to one variable. When I'm down to one variable, I can solve for that variable. So I'm going to solve for that remaining variable because I know that in order to solve this, all I have to do is divide by 8. When I divide by 8, I will have x squared equals 1. I know that at this point, all I have to do is take the square root of both sides, and that will give me x equals, and then the square root of 1 is 1. But remember, the square root was not already on the page. If it was already on the page, that would be principal square root, and that would indicate positive square root. But this square root was not already on the page, so that indicates the positive 1 as well as the negative 1. So what this tells me is I do have 2 points of intersection, and one of those points of intersection has an x-coordinate of 1, and one of those points of intersection is going to have an x-coordinate of negative 1. Now I need to figure out what the y-coordinate of that point of intersection is going to be. So remember, when we had that method of substitution, we said, well, once I figure this out, in order to figure out what the y is, I'm going to take that 1, I'm going to plug it back either here or here, and it doesn't matter which one, but when I plug it in, I'll be able to solve for y, and then I'll do the very same thing for the negative 1. So that's exactly what I'm going to do. I'm going to take this one, and I'm going to pick either equation that you want. I think I'll go with this one at the bottom. So what I'm going to do then is I'm going to take the positive 1, and I'm going to plug it in there, so I'll get 4 times 1 squared plus y squared equals 4. Now, order of operations says do the exponents first. 1 squared is 1, and 4 times 1 is 4, so that I have a 4 plus y squared equals 4. I'll subtract that 4 from both sides, and I'll get y squared equals 0. So now when I take the square root of 0 is just a 0. So that means that when the x is the 1, the y is going to be a 0. Well, now let's check out this negative 1 and see what happens. So when I take the negative 1 and I plug it in, and again, I think I'll use the bottom equation. It seems like it's working pretty well. I'm going to get a 4 times negative 1 squared plus y squared equals 4. And once again, order of operations says do those exponents first. Negative 1 squared is 1. So I'll have 4 times 1 plus y squared equals 4. 4 times 1 is 4. And once again, when I subtract 4 from both sides, I get y squared equals 0. And now when I take the square root, just like on the previous one, I get y equals 0. So that means that here are my 2 points of intersection. And so the solutions to my system are going to be a 1, 0 and a negative 1, 0. And just like we said before, we need to check this in both of these equations to make sure that they truly are a solution to the system. Because if this is a solution to this one but not this one, it's not a solution to the system. And similar idea here. So let's take that 1 and put it in here. And let's put that 0 right in here. Well, 1 squared is 1, and 4 times 1 is 4. And then 0 squared is 0, so 4 minus 0, yep, that works because it's supposed to be a 4. Well, let's test this down here in the bottom one. Once again, put a 1 in here. 1 squared is 1 times 4 is again 4. And once again, you put the 0 in there. Well, 0 squared is 0, so 4 plus 0, yep, it works. So this is definitely a solution to the system. Now let's check this one. Let's put our negative 1 in here. Now remember, order of operations says do the exponents first, so negative 1 squared is 1. Here again, 4 times 1 is 4. And we put that 0 in there again, and we get 4 minus 0 gives us 4. Same thing, it works in that one. Now let's check it in the bottom one. Take that negative 1, put it in for x. Negative 1 squared is 1. 4 times 1 is, again, 4. And let's put that 0 in here. 0 squared is 0. 4 plus 0 is still 4. So yes, both of these points are solutions to the system because they work in both equations. So, filling out the rest of our notes, once you solve for that remaining variable like we did here, we're going to substitute it into the original equation, just like we did right here. And then remember that we need to check the solutions in both equations because it has to be a solution to the system, not just one of the equations, but in both. And just remember that solution is a set, and that's why I put the braces around it. Now, let's take a look at our next example. That will lead us into these first two steps. As you look at that second example, notice that I'm ready to add, but the problem is that I'm not going to eliminate any variables at all. So sometimes I might need to do a little bit of manipulation in order to create those opposite coefficients that will allow us to add and eliminate. If you notice in that first example, what allowed me to eliminate these was we had opposite coefficients right here. So if I can create opposite coefficients, I'm gold. I can add up those, I can add the equations, and I can eliminate a set of variables. So that means that I need to sometimes multiply one or maybe both, sometimes both, equations by factors so that the coefficients of the x, now notice here that's x squared, but that's okay, of the x or the y are opposites. And that's the key. I'm going to put it in all caps because it's so important. They need to be opposites because if they are opposites, when I add the equations, they will eliminate. So let's go back to that example again. And notice that, like I said before, I don't have opposite coefficients, but I can certainly create opposite coefficients. What if I take the bottom equation and I multiply it by a negative 2? See, if I multiply that by a negative 2, I'm going to get a negative 4x squared plus a 2y squared equal to 4. And if I drag this one over as is, but check out what's going to happen here. Now when I add the two equations, the y squareds will eliminate and my y variable will be completely gone. It's awesome. So now let's add these x squareds up. So 3x squared minus 4x squared is a negative x squared. The y's will eliminate, and here negative 5 plus 4 is a negative 1. Now in order to get that x squared, I'm going to divide both sides by a negative 1, which basically will just simply change the signs. And now in order to get that x, all I have to do is take the square root. And remember, like I said before, since the square root was not already on the page, I do need to consider that positive and negative, and the square root of 1 is 1. So once again, like in the previous example, I do know that I do have a couple of solutions here. One of them having an x coefficient of positive 1, the other one having an x coefficient of a negative 1. So I need to figure out the y coefficients for these. So what I'm going to do is I'm going to take this positive 1, I'm going to throw it up into one of the two equations, and just like before, it doesn't matter which one. I think I'm going to go for the bottom one. There's a little bit less that needs to be done. So let's test out that positive 1. I'm going to put a positive 1 right here where the x is. So it will be 2 times 1 squared minus y squared equals negative 2. Now 1 squared is 1, and 2 times that 1 is going to be a 2. So I have 2 minus y squared equals negative 2. And when I subtract the 2 on the other side, I get negative y squared equals negative 4. When I divide by negative 1, I'm going to get y squared equals positive 4. And now I'm ready to take the square root. And once again, like I said before, since the square root was not already on the page, that does indicate plus minus, and the square root of 4 is 2. Whoa, how about that? So when my x was a 1, I had two options. I had a positive 2 as one of my options, but I also had a negative 2 as one of my options. So it looks like I might end up with more. Well, I'm definitely going to end up with more than 2 solutions here. Potentially 4 solutions. So let's see what happens. Now let's check out this negative 1. And so what I'm going to do is I'm going to plug that negative 1 where I saw that x. And again, I think I'll use the bottom one. It looks like it's a little easier to work with. So what I have was 2 times x, which is now a negative 1 squared, minus y squared. Oh, I'm scrunching this up. Let me move this around here. Make it easier to see. So 2 times negative 1 squared minus y squared equals negative 2. Now, exponents first because of order of operations. So negative 1 squared is 1. And so I have 2 times 1 minus y squared equals negative 2. 2 times 1 is 2. So I have 2 minus y squared equals negative 2. And yet again, when I subtract a 2, just like I had over here, I'm going to get a negative y squared equals negative 4. I'm going to divide both sides by a negative again, getting y squared equals 4. And once again, I'll take that square root, giving me the very same thing right here. Y is going to be a plus or minus 2. So similar idea happened here, that when it was a negative 1, I got 2 results. I got a positive 2 and I got a negative 2. Wow, 4 solutions on this one. And that can happen because these are curves. Curves are going to intersect all over the place. But remember, I need to check these solutions and make sure they work in everything. So let's check this one. Take that positive 1 and put it here. Take that positive 2 and put it here. 1 squared is 1. 3 times 1 is 3. So I get a 3 up here. And then take that 2 and put it in here. 2 squared is 4. 2 times 4 is 8. And 3 minus 8, is that a negative 5? Yeah, it is. And that's what I needed to happen. So now let's check this in the bottom one. 1 here. 1 squared is 1. 2 times 1 is 2. And now let's put the 2 in here. 2 squared is 4. So 2 minus 4, yep, it's a negative 2. So I know that this one works. Let's check this one. 1 and negative 2. Well, we already did. 1 squared is 1 times 3 is 3. Now we just need to fill in my negative 2 here. But remember, negative 2 squared is going to be a positive 4. Positive 4 times 2 is still going to be an 8. And 3 minus 8 is still going to be a negative 5. So let's check it down here. We already did. 1 squared is 1 times 2 is 2. So we just need to worry about this one. But here it happens again. Negative 2 squared is a positive 4. So yet again, 2 times 4 is a negative 2. It works in both. Now let's check these. Take that negative 1, toss it in here. But notice, negative 1 squared, again, is going to be positive 1 times 3 is 3. And we put that positive 2 in here, I'm going to come up with an 8 yet again. So that 3 minus 8 will still give me that negative 5. This does work in the top one. And now let's check the bottom one. Again, negative 1 squared will be a 1 times 2 is 2. And so here again, when we square that 2, we get a 2 minus 4 giving me a negative 2. It works in the bottom. And so it works in both. And the same thing's going to happen here because you're probably noticing now. I'm taking a negative 1 and squaring it, making it positive. I'm taking negative 2 and squaring it, making it positive, kicking back to what I did with this one. This is going to work. And so all 4 truly are solutions to the system. All right, let's take a look at this example here, and then I've got one more after that. So notice here, wow, crazy stuff happening there. But I can still eliminate a set of variables because I can eliminate those x's. So what I'm going to do then is I'm going to take my equations here. I think I'm just going to take this top one and multiply it by a negative 1. That will give me a negative x squared minus y squared equals negative 5. I'm going to carry that bottom one down. And even though I'm a little nervous, I'm feeling a little heavy on this one, at least when I add it up, I can eliminate those x squareds. So I will be left with a negative y squared plus a y minus 8 squared, and a negative 5 plus 41 will give me a 36. But notice I only have y's. When I only have y's, I can solve this. So I'm going to square this, which means it times itself. And when I do that, remember, it times itself will end up as the extended distributive property, or foiling. And when I FOIL this, I will get y times y is y squared. On the outside, I get a negative 8y. On the inside, I get a negative 8y. And in the back, negative 8 times negative 8 is a positive 64. So now, notice what happens when I combine up my like terms. Negative y squared plus y squared, they completely cancel out. And notice here that a negative 8y minus 8y is a negative 16y. And now, if I have a negative 16y plus 64 equals 36, I can just simply subtract that 64 on both sides. When I subtract the 64, I will get a negative 28. Is that right? Negative 28? Let me double check this real quick. And so now at this point, I'm going to divide both sides by that negative 16. And so I will get a positive 28 over 16, which will simplify because both are divisible by 4. And 28 divided by 4 is 7. 16 divided by 4 is 4. So once again, I know that I have some solutions, and I know that those solutions, I definitely have a y-coordinate of 7/4. And so I need to figure out what that x-coordinate is going to be for that y-coordinate of 7/4. So let's take that 7/4, and we're going to plug it back into either one. I don't know about you, but it looks like that's going to be easier to work with. So I'm going to take my 7/4, I'm going to plug it right here where this y is, and when I do, I get x squared plus 7/4 squared equals 5. Now when I square 7/4, I'm going to square the numerator and square the denominator, giving me 49 over 16. And then when I take 5 and I subtract 49 over 16, well, 5 over 1 minus 49 over 16, I need that common denominator of 16. And so 5 is going to be 80 over 16 minus 49 over 16. That will give me x squared equals 31 over 16. So now when I take the square root, remember, the square root was not already on the page, so that indicates plus or minus. I don't know the square root of 31, and I cannot simplify 31, but I do know the square root of 16 is 4. So therefore, I have two x-coordinates, one being the square root of 31 over 4, positive, the other one being a negative square root of 31 over 4. And so here are my solutions to the system. Now, we do need to check them, and the check feels kind of scary, but we can do the check because the squaring and the square rooting are going to end up canceling each other out, and it's going to work out just fine. So stay with me as I check. So what I'm going to do then is I'm going to take this square root of 31 over 4, and I'm going to put it right into this equation. My x squared plus y squared equals 5. Put my square root of 31 over 4 here. Whoops, that should be a 31. And I'm going to square it. And my y is going to be a 7/4. And I'm going to square it, and I better get a 5. Now, remember, squaring and square rooting cancel each other out. So I have a 31 over 16 plus a 49 over 16. And 31 over 16 plus 49 over 16, sure enough, is 80 over 16, and that, in fact, is 5. So I know that this one works in the top equation. I need to check it in the bottom equation. In my x squared plus y minus 8 squared equals 41. So here again, I'm going to put my square root of 31 over 4 here. I'm going to put my 7/4 here for the y. And here again, the squaring and the square rooting will cancel each other out. I've got a 31 over 16. Here, 7/4 minus 8, put the 8 over a 1, and now that common denominator is going to be a 4. Let me put that up here. So my 7/4 will subtract a 32/4, and 7/4 minus 32/4 will be a negative 25/4. And so now when I square that, 4 squared is 16. Now negative times negative is positive, and 25 times 25 is going to be a 625. So then 31 over 16 plus 625 over 16 is going to be a 656 over 16 And sure enough, when I divide a 16 into 656, I do get a 41. So I know that this works in the bottom equation. Now I need to check this one, but notice the only difference here is that the only difference between the two is this square root of 31 over 4 is negative. Think about what's happening here. When I put a negative in here and I square it, it becomes positive. So I'll get the same result. When I put a negative in here and square it, it becomes positive. So I'll get the same result. So yes, these two solutions do in fact work in both equations. They are the solutions to the system. Both of them are solutions to the system. So I have one more example to make sure we feel really confident with these nonlinears, because these are kind of tough. These give people trouble a lot. So one more example. So here we are on our last example. And remember, my goal is to eliminate a set of variables. As I'm trying to add these up, notice that's a y to the first power. So there is no way to eliminate the y's. I'm going to have to work on those x's. So what I'm going to do is I'm going to take one of the equations and I'm going to multiply it by a -1 in order to get those variables to eliminate. When I multiply that top one by a -1, I get a negative x squared plus 2y equal to -8. The bottom one, I didn't make any adjustments, and it feels kind of scary, but notice that when I add them up, the x squareds are gone. So now granted, I cannot add these as like terms, and that's what's making it feel scary, but notice that when I do add them up and I get a -8 plus 16 is +8, I have a quadratic. I know how to work with quadratics. I know that I need to set everything equal to 0, so I'm going to subtract that 8, and when I do, I can look at this and I can use any of those 4 quadratic methods. I can factor it, I can complete the square, I can do the quadratic formula, and I'm here to tell you if it will factor, it's much faster than quadratic formula. Now there's nothing common that I can divide out of each one of these, so I'm going to head for that double parentheses. And remember, back sign here tells me whether they're the same or opposites. It's a minus, that tells me I have opposite signs. My front slots come from here, so it factors as a y and a y. I want two numbers that are going to multiply for 8. They're going to subtract for a 2. That is a 4 and a 2. So now I just need to check my outsides and insides to make sure that they really do give me a 2y. Out here I get a -2y. Inside I get a +4y. Do those in fact give me a +2y? Yes, they do. So this is the correct way to factor it. So remember, my zero product principle says if I've got two things multiplied together to be a 0, one of these two's got to be the 0. So either this y plus 4 is the 0 or the y minus 2 is the 0. Because what I have is parentheses times parentheses. So one of the parentheses has got to be the 0. So if this is the 0, then y is going to be a -4 because I'm going to subtract 4 from both sides. If this is the 0, y is a 2 because I'm going to add 2 to both sides. So what that tells me is, okay, I do have solutions, and in one of the solutions I have a y coordinate of -4. In the other solution I have a y coordinate of 2. I need to figure out what the x coordinates are. So I'm going to take that -4, and I'm going to pick one of these two equations. I'm going to put that -4 in there, and I'm going to figure out what the x coordinate is. I'm going to make my life easy. I'm going to put it right here, because if I put it here, I have to square the 4, and I don't feel like doing that. So I'm just going to put it right up in there, and when I do, this is going to be for the -4. Let me write it this way, a little bit clearer to understand. Let me get these out. So when I check that -4, I'm going to put it, like I said, right here where the y is. And a -2 times 4 is 8. And so now when I subtract 8, I get x squared equals 0. When I take the square root, that means x is 0. So when that y is a -4, the x is going to be a 0. Well, now I'm going to check the y being a 2. And I'll use that top equation as well because it seems to be working pretty good. So I'll pop that 2 in for the y. 2 times 2 is 4, so I have x squared minus 4. I'm going to add that 4 to both sides, and that'll give me x squared equals 12. And now when I take the square root, now remember, square root wasn't already on the page. Since it wasn't already on the page, I do need to indicate the plus and the minus square root. Now I need to simplify square root of 12. Remember, 12 is simply 4 times 3, and the square root of 4 is 2. So I'm going to take the square root of 4 out. Let me write it this way. So I'm going to take the square root of 4 out, which is 2, leave the 3 underneath. So what that indicates is, oh, okay, wait, I don't have just 2 answers here. I've got 3. So when the y is a 2, my x could be a positive 2 square root of 3. Or my x could be a negative 2 square root of 3. So actually, I have 3 solutions to my system. And I do need to check all 3 to make sure they work. A little scary because of the square root, but they tend to work themselves out. So in my head, I can do the 0, negative 4. I'll put a 0 here, square it, I get a 0. Negative 2 times negative 4 is positive 8. 0 plus 8 is 8. Yep, that works. Let's check it down here. 0 squared is still 0. Negative 4 squared, well, negative times negative is positive. 4 times 4 is 16. 0 plus 16 is 16. Yep, that one works. Now let's check these. Let's check them in the top one. So when I put a 2 square root of 3 in here, I'm going to take that 2 square root of 3 and I'm going to square it. Minus 2 times 2 equals 8. Now, negative 2 times 2 is 4. Here's the tricky part. When you take that 2 square root of 3 and square it, you need to remember that that indicates 2 square root of 3 times another 2 square root of 3. Be very careful here. You've got 4 factors that you're multiplying together. It is 2 times 2, which is 4, and square root of 3 times square root of 3, which is 3, and 4 times 3 is 12. A lot of people will tell me that square root of 3 times square root of 3 is 3, and they'll do 2 times 3 is 6. Or worse, they'll do 2 times 2 is 4 and give it a 4 square root of 3. But you have 4 factors there that you're multiplying together. The result of this is going to be a 12. Now, 12 minus 4, yep, it's 8. So I know that that works in the top equation. So let's check it in the bottom equation. Once again, I'm going to square my 2 square root of 3, because I'm going to put that x right here. My y is a 2, but I'm going to square that 2. 2 squared is 4. We've already figured out that 2 squared of 3 squared is 12. Now what is 12 plus 4? Yep, it's 16. So I know that this one works in both. Now, once again, let's cut ourselves a break here. When I take that negative 2 square root of 3 and I throw it in here, it's going to be similar to this. The only difference is that that will be negative. But remember, negative times negative is positive. I'll still get a positive 12. So this will still work in that top equation. Similarly, in the bottom equation, when I throw that negative in here, once again, negative times negative will be positive. It'll still be a positive 12. So this will work in both equations. So therefore, it is a solution to the system. So I hope that this helps with the idea of being able to solve your systems of nonlinear equations. We skipped over this step right here. That step is just simply to write both equations in loosely said standard form. And it's loose standard form because exact standard form is ax plus by equals c. The main idea here is let's get all the x's and the y's together on one side. Let's get all the constants on the other side. Even if it is x squared and y squared, put them all on one side. Because when we add the equations, it will be much easier to see how things eliminate. And remember, the only way to eliminate those variables is to have opposite coefficients. You might need to multiply one or both of those equations by a factor to create those opposite coefficients. But once you've got them, go ahead and add those equations and then run with it because it'll be just like all those other methods. So I hope that helps. Have a great day.